Now this is the RJ11 connector, and RJ stands for register jack. And this is a 4-wire connector used mainly to connect telephone equipment. But as far as networking, the RJ11 is used to connect computers to local area networks through the computer's modem. The RJ11 locks itself into place by a hinged locking tab, and it resembles the RJ45, but it's a little bit smaller. Now the RJ45 is by far the most common network connector. This is an 8-wire connector used to connect computers to local area networks. And like the RJ11, it also locks itself into place by a hinged locking tab, and it also resembles the RJ11, but it's a little bit larger. Now the RJ48C looks very similar to the RJ45. The difference between the two is that the RJ48C is used with shielded twisted pair instead of unshielded twisted pair. It's primarily used with T1 lines, and it's also wired differently than the RJ45. A UTP coupler is used for connecting UTP cables with RJ45 connectors to each other. This is typically used when running a longer cable is not an option. You just plug one end of the cable into the coupler and then add another cable on the other side. And now you have successfully extended your UTP cable. The BNC connector is a common type of RF connector that is used on coaxial cable. BNC stands for Bayonet Neil Conselman, and it is used for both analog and digital video transmissions, as well as audio. A BNC coupler is used to connect together two coaxial cables with BNC connectors attached to them. This particular coupler is a BNC female-to-female coupler. If you wanted to join two fiber optic connectors, you would use a fiber coupler. Fiber couplers are used to couple or join two of the same fiber optic connectors. The two connectors have to be the same. Now these are not to be confused with fiber adapters, because fiber adapters are for joining two different connectors together, such as an ST to an SC, or an LC to an SC, and so on. So here we have an example of a fiber coupler joining two ST connectors together. Now this connector is called the F-type. Now this is a threaded connector typically used on coaxial cables. These are primarily used by cable providers to attach to cable modems. The F-type hand tightens by an attached nut. This is a USB connector. The USB is very common on desktops and laptops. Many manufacturers make wireless network cards that plug into a USB port. The USB has two different connector types, Type A and Type B. This is the IEEE 1394 connector, and this is also known as FireWire. FireWire is recognized by its D shape. This type of connection is becoming more popular on desktops and laptops, and is commonly associated with attaching peripheral devices such as digital cameras and printers rather than being used as network connections. These are also found on many types of video and multimedia devices. Now we're getting into fiber optic connectors. And this connector is called the MTRJ, which stands for Mechanical Transfer Register Jack. And this is a fiber optic cable connector. It uses a latched push-pull connection, and it has a small form factor used for high packed density. Our next fiber optic connector is called the ST, or straight tip. This uses a half-twist bayonet type of lock, and is commonly used with single-mode fiber optic cable. And our next connector is called the LC, or local connector. And this is also a fiber optic connector. It uses a jack similar to the RJ45. This type of connector is commonly used between floors in a building. And our last fiber optic connector is called the SC, or standard connector. And this uses a push-pull connector similar to audio and video plugs. And like the LC connector, this is also commonly used between floors in a building. The term serial refers to sending data one bit at a time. Serial cables are cables that carry serial data transmission, and the most common form of serial cables use the RS-232 standard, which uses the common D connectors, such as the DB9 and DB25. Now we're going to talk about the difference between UPC and APC connectors. And as an example, we're going to use a group of ST fiber connectors equipped with UPC and APC connectors. When fiber optic connectors make a connection to each other, the point at which the connection is made is not perfect because of the small imperfections of the surfaces. So what happens is at the point where the connectors join, light is transmitted from one connector to the other connector, but at that point where light passes to the other connector, light will reflect back in the opposite direction towards the light source. And as this happens, there is signal loss. This is what happens in a UPC connector. Light is reflected directly back. So as technology progressed, a new connector was developed to decrease this signal loss. And this is called the APC connector. The difference between the UPC and the APC is the angle of the tip where the connection is made. With the UPC, the light reflects back towards the light source. But with the APC, with its angled connection, the light doesn't reflect back towards the light source. It reflects back at an angle into the wall of the cable. And as a result, this greatly reduces the signal loss.